This is All India Radio, Power of Listening. Under this series, tonight we take you on a journey to the world of yet another magnificent facet of the Indian traditional knowledge system. In today's episode, we shall be focusing on the Sulba Sutra. Stay tuned.
All of us know that India has had a glorious past, and there are myriad facets of its saga of glory. Ancient mathematics is one of its major landmarks. The history of mathematics in the Indian subcontinent goes back to around 3000 BC. It is an amazing fact that thousands of years ago, people knew about calculations and measurements. They were not only aware, they had sound knowledge of many aspects of mathematics. When we go through the contributions of ancient mathematicians, it surprises us. They had derived a number of theorems and principles. Many of them were pioneers in several domains of mathematics. Let's talk to Dr. Hukum Singh, an eminent academician and professor of mathematics.
यथा शिखा मयूरा नाम नागा नाम मर्यो यथा तद वद वेदांग शास्त्र नाम गणितम मूर्धन स्थितम. Like crests on the heads of peacock, like gems on the hoods of cobra, so as mathematics on the top of all the Vedanga Shastra. Mathematics is mother of all sciences. We are very lucky that India's heritage about mathematics is very, very rich. All of you have heard that decimal numeral system was discovered in India, and it has been mentioned in our Vedas also. Vedic period is about 3000 BC to 1000 BC, and number system and decimal numeral system have been mentioned there. And even bigger numbers, 10 power 18 also available in our Vedic literature. Zero originated in India, and since number system was discovered here only, and even Einstein gave a statement that we owe to India who gave the decimal numeral system. Otherwise, we scientists would have not made any scientific discovery in the world.
There is a rich legacy of mathematical knowledge in ancient India. Our ancient Sanskrit literatures have the evidences of such knowledge. There are also many examples of mathematical formulas and their spiritual interpretation found in the ancient Indian literature.
In ancient time, in Vedic literature also, and in other literatures also, you see that mathematics was visualized through shloka, interpreted through shloka. I am mentioning one beautiful shloka. Om Purnamadah Purnamidam Purnat Purnamudachyate Purnasya Purnamadaya Purnmevavashishyate. 0 plus 0 is equal to 0, and 0 minus 0 is equal to 0. So this is a beautiful means as a sloka, and we are doing this as a Santi part, because whatever Sanskrit sloka was there, that a mathematical interpretation, and for our spiritual purpose also in our ancient literature. In Sulba Sutra time also, if you make the interpretation of the sutra, you will get the mathematical meaning also and spiritual their interpretation also.
In the field of mathematical knowledge, India has done much and achieved a lot. Ancient and medieval mathematical works in India were composed in Sanskrit, and Sulba Sutras constitute the major landmarks of Indian contribution in the field of mathematics. In our country, mathematical knowledge was transmitted orally until 500 BC, and thereafter that was transmitted both orally and in manuscript form. In ancient India, people were much aware about the practical use of mathematics. Bricks used in the Indus Valley civilization were in the proportion of 4:2:1, which is still considered favorable for the stability of a brick structure. Excavations at Harappa, Mohenjo-daro, and many other sites of the Indus Valley civilization have uncovered such evidences. They also used standardized system of weights based on ratio. Our ancient mathematicians had a sound knowledge of geometry, and they produced weights in regular geometrical shapes like cones, cylinders, and hexahedra. During the Indus Valley civilization, standardized measurement of length was made to a high degree of accuracy, and a ruler was also designed in that period, which is popularly known as the Mohenjo-daro ruler. In the Vedic period literature, the use of large numbers is documented. In the text of the Satpat Brahman, rule for ritual geometric constructions are written.
Mathematics deals with measurements, and in this discipline of knowledge, length, area, height, and volume are measured in order to understand the pattern and symmetry of any structure. This specific knowledge was started with the rudiments of metrology and computations in prehistoric times. We also have a number of mathematical treatises and literary works which witness the glorious past of India's mathematical ability. The sacred literature, the Samhitas, the Kalpa Sutra, and the Vedanga, all of these contain enough materials which prove our mathematical heritage.
The period 3000 BC to 500 BC is an ancient period of mathematics in India. And this period can be divided in three parts. The first is about Vedic period, that is 3000 BC to 1000 BC. And during the Vedic period, the geometrical shape of circle, pi, the ratio of the circumference of the circle with the diameter was given. Pi is equal to 22/7. 4 Vedas were written. The Rig Veda, Yajur Veda, Sam Veda, Athar Veda. And in all these 4 Vedas, the mathematical results related to geometry, related to number, arithmetic, the fundamental operations were mentioned in our Vedic literature. Even the prime number concept was also given in the Vedic literature. And the second period, 1000 BC to 500 BC, is Sulba Sutra period. 5 names are very, very famous, and they are Baudhayan, Mano, Apastamba, Katyayan, and Pingla. By these 5 Indian mathematicians, number of results related to square, rectangle, and extended form of the square or reduced form of the square were given in Sulba Sutra. And using that Sulba Sutra, our yagna were performed, because for performing the yagna, different types of altars have to be made, and for different types of altars, different types of geometrical shape were used.
Kalpa Sutra is an important source of Vedic mathematics. One of the key sections of this Vedic literature is the Srota Sutra, which talks about directions for laying of sacrificial fires for Agnihotra. Let us try to understand the evolution and genesis of Sulva Sutra. The word Sulva means a cord, a rope, or a string, and it signifies the act of measurement. In this way, the works discussed in Sulva Sutra are a collection or a compendium of rules, and these rules discuss the measurements with the help of a cord of various linear, spatial, or three-dimensional figures. Sulva Sutra are concerned with geometrical propositions and problems relating to rectilinear figures, their combinations and transformation, squaring the circle, circling the square, as well as arithmetical and algebraic solutions of problems arising out of such measurements and constructions.
In ancient times, measurement was made with the help of a string. And if you see the Sanskrit literature of Sulba Sutra, 9 mathematical results were given in the Sulba Sutra. The first, if we have a square, we take the square and make the diagonals. Then the 4 diagonals, again with the help of cord, Sulba, if we have 4 triangles, congruent triangles. If we have a rectangle and make the 2 diagonals, then it again will be divided in 4 parts, 2 pair of isosceles triangle and 2 pair of, again, acute angle triangle. And again, if we take the rectangle and we stretch the rectangle, that the area made on that diagonal will be sum of the area on the remaining two sides. Another mathematical result of the Sulba Sutra is that if you have a square with unit side, then diagonal will be represented by under root 2, means irrational number. So even irrational number were also mentioned in our Sulba Sutra.
Ancient Indians used mathematics in all walks of life. The excavations of the Indus Valley civilization brought forth several wonderful evidences of mathematical measurements. The Sulba Sutra talks about the rules for the construction of Vedic fire altars designed by Brahma Bhatta, a Vedic priestly class. Almost all the rules described in this Sanskrit text of Sulba Sutra pertain to the construction of various shapes of Vedic fire altars. There were definite structures of these altars, and mathematics was the catalyst behind those structures. Those Vedic fire altars required 5 layers of bricks, and each layer contained 200 burnt bricks. Also, there was a perfect harmony among all the layers. It may seem as an ordinary mathematics problem, but for the construction of these fire altars, trigonometry is required. The Sulba Sutras, which depict the construction of Vedic fire altars, belonged to different Srota Sutras. There are Srota Sutras, which belong to all the 4 Sanhitas of ancient Indian literature: Rigved, Yajurved, Samaved, and Atharvaved. Today, we have the understanding of only a few Sulba Sutras, which are attached to sutras belonging only to the various schools of the Yajurved. Among them, the Black Yajurvedans of the Taittiriya school were the most active. They produced the most comprehensive Sulvas, which were of Bodhayan, Vadhula, Apastambha, and Hiranyakeshan. There are 2 Sulvas by Manav and Varaha of the Maitrayani, and 1 by Logatsi of the Kathak Kapisthal school. Of the White Yajurvedans, Katyayan, the prolific Sutrakar, is credited with a small but more scientifically executed Sulva literature.
Bodhayan was a great Indian mathematician of ancient times. Based on the ancient mathematical literature, it is supposed that Bodhayan was the pioneer who put the concept of Pythagoras Theorem. This theorem was indeed known much before Pythagoras, and in India it was discovered around 200 years before Pythagoras. The credit for authoring the earliest Sulba Sutras goes to him. Bodhayan Sulba Sutras contain Pythagorean triples along with the statement of this theorem for the sides of a square. Bodhayan also gave the expression for the square root of 2. So, we find out the fact that the Bodhayan Sulba Sutra tells us the rule referred to now in most of the world as the Pythagorean Theorem. A number of ancient civilizations, including also the Greek and the Chinese, were familiar with this rule. During around 1800 BC, in Mesopotamia, it is recorded. So we find that it is really the Bodhayan Sulba Sutra which tells the rule now referred to in most part of the world as the Pythagorean Theorem. A number of ancient civilizations, including also the Greek and the Chinese, were familiar with this rule. And it was during around 1800 BC in Mesopotamia that it was recorded. The rule written in Bodhayan Sulba Sutra is
Dirgha chaturasrasya akshanaya rajjustiryang mani parshvamani cha yat prithak bhute kurutas tadubhayam karotiti kshetrajnanam.
A rope stretched along the length of a diagonal produces area in which the vertical and horizontal sides are taken together. The diagonal and sides referred to belong to a rectangle, and areas are those of the squares having line segments like their sides. Diagonal of a rectangle is the hypotenuse of a right triangle formed by two adjacent sides. This is equivalent to the Pythagoras theorem. Bodhayan also explained the Pythagoras theorem by using a rope measure.
Bodhayan, Manav, Apastamba, Katyayan and Pingal were involved in the composition of Sulba Sutras. You may discuss the text of prominent Sulba Sutras and simple explanation of triplets. Dr. Hukum Singh now tells us about the text of prominent Sulba Sutras and simple explanation of triplets.
Sulba Sutra period is 1000 BC to 500 BC, and during that period Bodhayan, Manav, Apastamba, Katyayan, and during that time different types of Pythagoras triplets were used. Triplet 3, 4, 5, 5, 12, 17, 8, 15, 17, 7, 24, 25, 12, 35, 37, and later on Pythagoras also used different triplets. Lot of triplets have been discovered in the Sulba Sutra. Bodhayan took one of the diagonal of the rectangle and made a square on the diagonal and showed that area made on this diagonal is sum of the area on the remaining two sides. The simplest triplet I am giving 3, 4, 5 means if we have a triangle of one side is say 3 centimeter, the second side is 4 centimeter, and if hypotenuse is 5 centimeter, then 3 square is 9, 4 square is 16, so 9 plus 16 is 25, and hypotenuse is 5, so 5 square is 25, so 3 square 9 plus 4 square 16, so 9 plus 16 is equal to 25. Different mathematicians used different triplets and showed that the sum of the two sides equal to the third side.
The Bodhayan Sulba Sutra is the oldest, which belongs to a period from 600 to 500 BC. This is the most voluminous work of such an ancient text. It comprises 525 sutras and is divided into 3 chapters. The first chapter consists of 116 sutras, which gives geometrical propositions required for the construction of altars and deals with their relative positions and spatial magnitudes. The second chapter consists of 86 sutras, and the chapter describes different fire altars and their spatial relationships with other substances. The third chapter has 323 sutras, and this chapter is devoted to Kamya Agnis or sacrificial altars designed to attain desired ends. Manav Sulva Sutra is a part of the Srota Sutra. It is a small compilation which gives specifications of the measuring tape, gnomon, and methods of finding cardinal points. These elements were not described by Bodhayan or Apastamba. It elaborates descriptions of a number of altars. For example, the Suparnasiti, the Pakaya Janiki, the Marathi, and the Varuni. The period of the Apastamba Sulva Sutra ranges from 500 to 400 BC. It has 223 sutras distributed among 6 chapters. Apastambha covers the same ground and gives the same rules as was done by Bodhayan. The Katyayan Sulva Sutra was written during 400 to 300 BC. It is also known as Katya Sulva Parishishta, which is a comparatively small text of 102 sutras arranged in 6 chapters. Katyayan's treatment of mathematical derivations is more systematic. Like Manav Sulva Sutra, Katyayan also gives specifications of the measuring tape, discusses the gnomon and its application in determining the cardinal points. Katyayan had given solutions of rational triangles and described the Pythagorean theorem in a generalized form. In the Sulba Sutra, Katyayan deals with different Agnis and their spatial relations, but not with the Kamya Agnis, because it is discussed in a separate chapter of his Sulba Sutra. Dr. Hukum Singh tells us about the measurement of ratio of the circumference to diameter as discussed in the Sulba Sutras.
In Vedic literature, the concept of circle was given, but in a very systematic way, the ratio of the circumference of the circle with the diameter was also mentioned in the Sulba Sutra. Different types of ratio have been considered in the Sulba Sutra, such as 676 upon 225, 900 upon 289, 1156 upon 661, and decimal representations are also available in the literature. The decimal representation is about 2.99, about 3.004, about 3.029, about 3.074, about 47, about 3.088. The ratio was given by Mano also. Mano took the ratio 25 by 8. But it is very interesting that Aryabhatta, when he wrote the Aryabhatiya at the age of 23, he gave a beautiful approximation, the best approximation which is found correct to the 4 decimal places, and that we are using at present in India also and other parts of the world also. Bauddhayan took 62,832 upon 20,000. If circumference of the circle is 62,832 and diameter of the circle is 20,000, and you divide 62,800 to 20,000, then you will get value in decimal form 3.1416. But it is the best value which we are using in our present day for computational purpose also. So this was the best approximation given by Aryabhatta.
Every one of us has grown learning many scientific theories, chemical equations, and mathematical theorems. In the mathematics syllabus of school, we have studied the Pythagoras Theorem. This theorem has an important place in mathematics. It explains the relation between 3 sides of a right triangle. This theorem is basically used to find the length of an unknown side and angle of a triangle. By this theorem, base, perpendicular and hypotenuse formula can be derived. This theorem was proposed by the Greek philosopher Pythagoras, who was born in the 6th century BC. It is a historical fact that the Pythagorean theorem was known and used by the Babylonians and Indians centuries before Pythagoras. But he may have been the first to introduce it to the Greeks. Following the suggestion of his Egyptian teacher, Pythagoras made a special trip to India. He came to our country to learn the principles of mathematics that were rooted in the ancient Sanskrit text of Sulba Sutra. The ancient Indian mathematician Bauddhayan is supposed to be the pioneer of the mathematical concept of the Pythagoras Theorem.
Sulba Sutra and Pythagoras Theorem are closely connected with each other. But the time periods of both literature
Time period of Sulba Sutra discovered by Bauddhayan, Mano, Apastambha, Katyayan, and time period of Pythagoras is different. The Sulba Sutra was given between 1000 BC to 500 BC. Pythagoras theorem was given in about 600 BC. So there is a lot of time gap. Basic difference is that Bauddhayan took a rectangle and took one of the diagonal of the rectangle of side A and B and showed that if we make the square on the diagonal of the rectangle, the diagonal will be under root A square plus B square. If we make the square on this diagonal, the area of the square will be A square plus B square, and area on the remaining 2 sides of the rectangle will be A square and B square. If you add A square and B square, again A square plus B square, so area made on the remaining 2 sides is equal to area made of the diagonal of the rectangle. And Pythagoras took a right angle triangle of sides A, B, C. So a square plus b square is equal to c square. So Pythagoras took right angle triangle beside ABC.
It is true that ancient Indian mathematics had a very strong foundation, and Sulba Sutra is one of the pillars of India's mathematical achievements. When we study this segment of ancient Indian mathematics, we find that it was evolving those days. For example, in the early Sulva period, ratio of the circumference to diameter was thought to be 3. It is seen in a Sutra of Bodhayana. But when we go through Manav Sulva Sutra, a new value was proposed. But as we know, scientific knowledge is based on logic, experiment, and analysis. Difference in measurement values not only shows the evolution of knowledge and understanding, but it also reflects the rationality of ancient Indian mathematicians. The Indian legacy of mathematics has many milestones as well. The discovery of zero and the decimal numeral system are the two major landmarks of ancient Indian mathematics. India's legacy in mathematics not only transmitted orally, but is also well documented. And Sulva Sutra is one wonderful example of this. Such manuscripts of the mathematical knowledge of our country must be preserved and catalogued properly for successive generations. This would be the best honor to this rich mathematical heritage and our great mathematicians. We conclude with heartfelt thanks to Professor Hukum Singh for sparing time for the sake of our listeners. Continuing our attempt to revisit our rich legacy, we shall be back with the next episode with some more interesting and fascinating aspects of the Indian traditional knowledge systems. Do join us on this enlightening journey. Bye for now.
Power of Listening. You heard the third episode of our all-new series on traditional Indian knowledge systems, Power of Listening. We shall be back on the second Friday of next month, that is the 8th of October, same time with another episode taking you on a journey through our glorious traditional Indian knowledge system. This program was scripted by Dr. Manish Mohan Gore and the expert on the show was Dr. Hukum Singh. The narration was rendered by Manoj Mayankar. Additional voicing was done by Kiran Mishra. Special thanks to Randhir Thakur and Amol Parth for their contribution. This series has been conceptualized by Shashi Shekhar Vempati, CEO Prasar Bharati, and produced by Vinod Kumar. The episode is also available on our official YouTube channel, AkashvaniAIR. Be there on the 8th of October, same time, same frequencies. Bye for now.